And it's very important really to test all these things, not only in the laboratory, but really in the real life, in the real life situation. And this brings me to our first presenter of this morning, Dr. Alexander Viehl from the Research Center for Information Technology from Karlsruhe, short the FZI. Alexander, it's really nice to see you in person this morning. We saw a lot in the digital space during the last month or during the last year. So I'm really happy to have you here. Before you start your presentation, some short words. You have a master's degree and a doctorate in computer science from the Karlsruhe Institute of Technology, short KIT, in the University of Tübingen. It's my alma mater too, so perfect. Yeah, you've been working at the FZI since 2004, and you are head of the division Intelligent Systems and Production Engineering. And yeah, just for your introduction, so I'm happy that you are here, and I'm looking forward to your presentation and to discuss some other aspects later on in the discussion. The stage is yours, Alexander. Thank you.
Thanks, Wolfgang, especially for the kind introduction. I'm also happy to be here and have a kind of a physical meeting under special circumstances. Yes, so when I was asked to give an overview about our test area for autonomous driving, we built up here in Baden-Württemberg. Of course, I agreed, but however, I think for the Hannover Trade Fair, it's important to also show, how it can be used. So not just the technologies in the test area, but also how it can be used for innovation and transfer, which means how to bring fresh ideas, how to bring technologies to the market, how to foster industrialization. So when you start discussing about kind of a test area, the people say, oh, well, what do you tell me? It's just for testing automotives, I guess. So, but basically for understanding what the real purpose is that you need to understand what are the challenges and demands for autonomous driving. Of course, this is a very, let's say, technology-driven area, so you need to consider technology, but also aspects of validation. So do the technologies really fit to the field? Do they really fit to the requirements in the field? Yes, but as you know, it's not just the driving itself, especially if you remove the driver, there may arise new mobility concepts and business models. But at the other hand, you also need to involve the user. So the social acceptance is necessary to be considered, and this is a very important aspect for such a test area. And as well, as we also heard in the introduction from Wolfgang, legal aspects play a significant role. And all those aspects together need to be considered for autonomous driving as well if you create an appropriate test area for such things. And usually you have some iterative improvement in all the areas and not just one area that is solved and then the others will follow. So this means we need such a test area for more than just testing. It's also an enabler for different use cases that can be built up onto the test area. This means what we are doing there is an application of digital infrastructure, meaning it's smart and intelligent for the automatic public transport or of goods and people. This means that the infrastructure can be used for the testing, but also to be part of the system, especially if you use some sophisticated technologies where, for example, you would remove the intelligence from the vehicle and bring intelligence to the infrastructure. And in addition, you produce in such a test area lots of data you can use, for example, as live reference data from the infrastructure for the testing, but also to use the information, for example, into your vehicle to fuse together the impression that the vehicle has and what is provided by the infrastructure. If, for example, you're missing to detect an object outside of the vehicle. And this means we need a very sophisticated and complex setup of sensors that provide data, but also of the communication that brings the information from, for example, this infrastructure to the vehicles or among the infrastructure. This means we have, for example, multiple cameras that are equipped inside the test areas that can acquire the microscopic traffic, but also to have some roadside units that help in the communication between the infrastructure and then the vehicles. And then the question is, what do you do with all the data? Maybe you need a big database in the background to store some data, but you also need then some processing power that is connected, for example, to a backend in order to detect or to fuse some higher level information together. And basically, as this is a huge infrastructure, you also need some properties such as condition monitoring of the entire test area to know what works, or maybe if there's somewhere a problem you need to fix, or if this is a new aspect that poses new research questions. So one use case, I talked about use cases, is there, for example, the infrastructure supported driving. This means, on the one hand, on a very local basis, we have a smart roadside infrastructure that provides efficiency and safety of the autonomous mobility by supporting infrastructure. On the one hand, this means, for example, that the infrastructure supports or provides some reliable perception of the traffic participants and also provides real-time communication and advice if a system is not really sure what to do or which alternatives exist. This means at that aspect, the smart roadside infrastructure enables safety and some core functionality for the technical systems. On the other side, you also have some aspects of global connectivity and interoperability. This means, based on such a digital infrastructure, you can create globally optimized services, for example, to improve public transport and also to bridge transport of people and with logistics of wares and goods. And if you would then put this into the global context and allow connectivity among different services and systems, you can have additional synergy effects that would lead at the end to a more efficient and green usage of resources. So this means, using such global visions, a test area can foster a technology spread and serve as an innovation platforms, not just on the very local side. So let's have a look what does digital infrastructure look like and what are the building blocks, the basic building blocks we foresee there. So this is a sketch of a city you see here, and there are different aspects and different building blocks you see. For example, we have intelligent traffic lights that communicate with the vehicles. We have some additional mobile sensing. This could be the traffic sensors, this could be weather sensors or some other conditions. Then we have the communication aspects I already referred to, meaning, for example, using LTE vehicular, 5G or Wi-Fi connections that are available there. Then one very, very crucial aspect is the intelligent environment and sensors that provide additional data to support, for example, the driving or the testing. Then we need some background information, for example, high definition or high precise maps that can be used to support the driving or, for example, to test some detection algorithms. Then we have the roadside units and some additional intelligent transportation systems communications and some back-end that on the one hand provides services that on the other hand can serve as kind of a digital twin in order to find some problems that might arise, but those during the simulation, this means they're also reproducible. And something to really say, you cannot just create a test area inside a living city, maybe outside in a city in an industrial area, but you need lots of support. You need a network, for example, the governments, the legal bodies, certification units, but also then industrial partners that provide technologies you need. So far from the general concepts, now I would like to show a little bit about the physical deployment. So how does the test area look like so far? And yes, as it's called Test Area for Autonomous Driving Baden-Württemberg, it's not just deployed in Karlsruhe, but I would like to take a very interesting area in Karlsruhe in order to show you what has been done. So on the left side, you see a map that shows the eastern part of Karlsruhe, or just a part of the eastern part of Karlsruhe, between the highway A5 and, let's say, the center of the city. And there's the road network. And what you see here maybe is the pink tracks are the tracks in that area where we have this high precision 3D maps. And then there are two different kinds of circles, the red circles and the gray circles. And the red circles have a full sensor setup. This usually means they have cameras, they may have LiDAR sensors, or they may have, for example, also radar sensors in order to do some additional, let's say, for example, perception analysis steps. And then there are the gray intersections that have support of car-to infrastructure communication. Means at this point, for example, the information of traffic lights are communicated to the vehicles. Yes, but how does it look like? I depicted here two examples from different intersections. So the upper picture is, yes, an aerial image of an intersection, and right next to it you see what it means. So the intersection existed, and it's an intersection that also integrates public transport, rail-based public transport, and there we had to equip a lot of sensors, but also to create the connectivity inside this intersection for being able, for example, to stream the data, to analyze, to have a computational pipeline that identifies objects, characterizes them, and stores necessary or interesting information, such, for example, yes, movement directories or movement patterns. On the lower part you see a different intersection, and there you see, for example, some information that are stored in the back end of the test area. So, for example, what we are not doing, also especially due to the GDPR, is to store raw data, but what we are doing is, for example, to detect and classify objects. And what you do then see in this moving area, that there are some objects with a certain speed and a trajectory that are somewhere in time. And on the lower image you see, for example, the different lanes that are in the intersection and the status of the traffic lights that say, okay, this is green, red or yellow so far. So just for giving you a glimpse what we are doing in the test area with the different technologies. And for coming to innovation and transfer, I think you have now seen that it's not just testing vehicles, it's also to support the creation of new services, and one strong instrument for really bringing companies to that area. This means some companies already have, let's say, their development stack, their development plans for going towards, let's say, autonomous driving. But there are also other companies that would like to get in touch with this topic area, or to develop services that are not fully related or necessarily related to autonomous driving. And I think that public-funded research projects are very good to bring innovation and transfer, also using such a test area. And I listed here some examples of projects that are currently running on this test area. For example, the project EVA shuttle, which means electrified, connected and autonomous shuttle buses for the last mile, which are deployed in southern Karlsruhe in an area where they serve since yesterday the public transport. So this means they're transporting people powered by an app. And here one of the challenges was that you're not serving some predefined routes, so that it's on demand. You can call via an app on demand using the test area infrastructure, such an automated shuttle bus, and say where you would like to be brought. Then there's a very huge activity called SHOW, financed by the European Union. And there's the test area is part of the mega site Germany there in Karlsruhe. And what we are doing is to demonstrate different autonomous driving technologies, especially with emphasis on public transport. And there we also explore not just transport of persons, but also of goods as a first initiative. And then there are, I would call it different activities, for example, funding program by the state of Baden-Württemberg called Smart Mobility with several projects. Then there's the high performance research area called Profilregion Mobility Systems, which, for example, establishes a virtual test bed of the test area Baden-Württemberg for the verification of driving functions. And then there's, for example, this Lighthouse project family from the German automotive industry, association VDA called Connected and Autonomous Driving, and there's a lot of projects, and at all we just summed up how many projects are actively working currently on the test area, and it's at least 20 projects I counted yesterday, and the number is growing. I think we have lots of interesting new projects in the pipeline, and when counting the institutions that are part of the projects. And institutions does not just mean research institutions, it's also large industrial companies, it's SMEs. We count more than 130 institutions that have directly or indirectly within projects access to the test area, and then, develop things, try new things out, and test vehicles. So, for concluding, what I said is, from our point of view, the test area for autonomous driving Baden-Württemberg is an open innovation platform for research and transfer projects, and hence contributes to the industrialization of lots of those autonomous driving technologies. Thank you.
Yeah, thank you very much, Dr. Alexander Viehl, for the insights in the testing area for autonomous driving. I always call it tough BV in my mind, so that's the short expression around it. As we have 20 seconds left, maybe a short answer. Just if we talk about small and medium-sized companies, from your perspective as a researcher, what is your advice for them? Is it really going into joint projects with the research institutes?
So anyway, I would always say be fast. Whatever you want to do, be fast. Because if you're fast and have a good idea, there's a market. And I think that research projects are a very good vehicle, but you need to take care that maybe even if it's a 3-year project, that after certain, let's say, milestone, internal milestone, you already have something that is kind of results that you can then bring to the market, bring to products. But I think in this, let's say, in this area where you have then the collaboration with the big industries that might be your first customers, and then also with the, let's say, research institutes, with the universities that have the latest technologies. It's a very good aspect. And then if you have a test area, it's a very good setting for starting to make some successful business.
Thank you. We can go more in detail in the panel discussion. So thank you very much for now.
You're welcome.